Hello and welcome to the Cisco ACI Field Engineer Implementation, Module number 3, the Application Policy Infrastructure Controller, or APIC. In this, we will go over the APIC, we will go over ACI deployment options, the APIC installations, and we will also take a run through the APIC GUI. What is the APIC? So the APIC is the Application Policy Infrastructure Controller. It is the policy controller for ACI. The APIC is not in the data path nor in the control path. It contains the management configuration and is a policy repository. They are ordered in sets of 3, and honestly, basically, any prime numbers work, except for higher than the max limits. You need to order in sets of 3. Because what actually happens is if you order a 4 or a 5, you end up overloading the controllers and how they operate from a redundancy perspective. So always order in sets of 3. Provides a highly redundant cluster of 3 servers. The factors associated with the scalability are the numbers of spines, leaves, policies, endpoints, contracts, and other pertinent information. You can actually see that generally in a mid-level configuration, 1,000 ports and under. It's an Intel Xeon, 64 gig of RAM, 1 terabyte flash drive, VIC card. It runs on a CentOS 7.2 kernel, and it includes Cisco software and the Fabric certificates. The APIC is a multi-purpose built C-series rack mount servers. Their current support is RMA, the whole server, even if an individual component fails. So the APIC consists of a management API. Any sort of RESTful client can interface with the APIC. So the APIC has 4 different functionalities: policy, topology management, observer, and boot. Okay. Under policy is, of course, the definition: tenants, VRFs, bridge domains, contracts, CPGs, policy consumption of those states, who can see who and where, and the endpoint registry. The topology is the condensed state of health of the entire topology, both physical and logical. The observer handles statistics, fault alerts, state, health, and also stores logs and history. And then the boot is another function that we're really not that used to when it comes to network devices. Usually network devices boot up and they boot up independently. But here, the spines and leaves actually look to the APIC for the boot device and the Fabric node images. So it's a little bit different. The APIC itself is the boot repository for all of the node devices. So think about this. All nodes will be assigned an IP address, and each will be classified as a VXLAN tunnel endpoint or a VTEP. Software load is managed by the APIC for itself and all switch nodes, leaves, and spines. So you can see in the fast distributed data store, in an N+2 replication, the distributed data store refers to the fact that we have 3 or more APICs. Possibly could go a lot higher, but remember, always in 3s. The data store is replicated across all APICs, and you have an original plus 2 copies. And we'll actually see that in the next slide. In the next slide, the actual APIC clustering, the data is sharded, okay? So these functions are spread across all 3 APICs. The shards are only sized based upon the 3 APICs. The replication factor is N+2, so we have a preference with 2 copies. In this case, this slide shows a 3-node cluster. Each shard will touch all 3 APICs. The preference designation specifies the preferred copy. 1 is the highest. Writes are made to the highest preference, then replicated out. If shard 1 goes away, number 2 is then promoted to the highest available shard, and the writes are made to 2 and replicated to 3. When a former shard 1 comes back online, it'll sync the database. The shard preference dictates where writes happen to the highest preference reachable point. Sharding provides scaling, spread out processing. Replication then replicates fault tolerance, so each shard has 2 copies. So you can see shard A and shard B for policy. You can see it's split up amongst all 4 as well. So we have different shards for different functions. The shards are evenly distributed, and no data is lost as long as only 1 or 2 APIC appliance. No data is lost as long as only 1 or 2 APICs survive. So mean time between failure of n plus 2 is way better than n plus 1 for obvious reason. Sharding provides the scaling. So APIC clusters are limited to 3 nodes, possibly will grow higher in certain cases. So let's actually talk about horizontal scaling. Simplifies replication scope. Each shard has primary 2 replicas. We've already discovered that. Changes are written to the highest preference. Processing is evenly distributed. Okay. Now, automatic reconciliation gets rid of split brain circumstances as well. Let's talk about an unrealistic case. Someone breaks into my data center and decides to unplug the exact 3 APIC servers and leaves everything else untouched at exactly the same time. The network will continue to run. Every switch operates correctly. VMs can move, links can go up and down, and no operational impact. So if there were 4 APICs, let's just say that we added another APIC, shards of data that lived distributed amongst all 4 APICs, some shards of data would only live on nodes 1 and 3, whilst others would live on 4. If that horrible administrator destroyed 3 of those servers at the exact same time, you would lose some data. Whatever's been sharded only across those 3 nodes, because it would not have yet been able to be replicated to the 4th. So each APIC node has all APIC functions processing evenly distributed. Each shard has a primary and 2 replicas. The observer collects statistics, events, faults, and logs. Predetermined weighting system. So the observer takes in all these different measurements and observations, then renders a number for the health score. Along with the global health score, each tenant has its own health score. Administrators can determine health scores for a given context. The idea is to isolate based on function, state, drops, etc., as well as faults, forensics diagnostics. You could see a low health score if you have ports with SFPs plugged in, but they haven't been configured yet. So think about it like this. Only if you want to see consistently high health scores, ports in use versus ports that are not in use, like if you took an EPG and applied it to, let's just say I wanted to be lazy and I wanted to put the same EPG on 30 ports. Because I might, and I've had customers ask me this, unplug and then plug that cable into another port on my switch. Well, that's fine. Trouble is I'm going to have a 20% health score on my switch because I have EPGs applied to ports and there's no traffic routing on those ports. So we have to understand that just because we can do those configurations, it's the same from a standard switch. You wouldn't want to go configure all 30 ports to do the same thing, because you would actually get errors as well in a standalone switch. So if we think about multi-tenancy, it's some sort of separation, traffic, services, or management. So ACI's first level of partitioning is the tenant. So this is a logical model, and from a hierarchical perspective, you can specify different levels where you want visibility and lock it at different layers based on functionality. So if we take a look, you can authenticate between those 3 authentication methods. Role-based access control controls read and write for all managed objects. So if you have a tenant and you create an administrator for that tenant, he's only going to be able to provision those objects that are under the tenant. If you have an administrator and he's administrator for the whole fabric, then he's going to also be able to make configurations for the tenant, but he's also going to be able to completely administer the fabric as well from a holistic perspective from the hardware point of view. So the APIC controllers communicate via the fabric in band. So what actually happens is that topology discovery is through LLDP using ACI-specific TLVs. So loopback and VTEP IP addresses are allocated from the infra VRF through DHCP and from the APIC. So the APIC uses in-band connectivity for node communications. ACI exploits the capabilities of LLDP, which allow APICs and leaves to discover each other. All nodes require an administrator to validate the serial numbers and provide names. You can validate the serial numbers up front prior to physical connectivity. Now, this is where things can get really cool. You could actually use Postman, and you can actually write a runner script to actually go ahead and write those fabric devices and go ahead and pre-validate them. That way, when you rack them and power them up, they'll automatically get discovered in the fabric, and you want to do right-click, add it, give it a node ID. Especially if you're doing 50 switches, it gets to be ridiculous to just right-click and I want this to be node 102, I want this to be node 103, I want that to be node 104. So you can very easily do that with a Postman, and we'll actually show you how to do that in the lab in this course. So the ACI Fabric supports discovery, boot, inventory, and systems maintenance through the APIC, fabric discovery and addressing, image management, and topology validation. So you can see here you've got the GUI, you've got the CLI, and you've got a REST API. GUI, of course, is GUI. CLI is CLI. Now, you does show the APIC in the leaves. You can do show commands on the leaf, but you're not going to be able to do config commands or do anything on the leaf switch itself or spine. You're going to actually do those configurations from the APIC itself. And here's the REST API, which here we're using Postman, and you can actually create by picking the right URLs and adjusting the payloads. You can actually script out or post changes that you want to make to the physical fabric, which actually goes into the open APIs and open source of ACI. So there's a Python software development toolkit. There's ACI-enabled fabric devices. There's also Layer 4 through Layer 7 scripting. Talk about that later. But this is object-oriented, so it's comprehensive access to the underlying information model, consistent object naming directly mapped to a URL. It's very easy to find as well. Supports object, subtree, and class-level queries. It's RESTful over HTTP or HTTPS, JSON plus XML. Of course, XML is going to be a little bit easier to read than JSON, but that's just my opinion. So the APIC is based on a hierarchical object model. Everything is represented as an object, and every object can be manipulated via REST. The REST operations are post, get, and delete, supports for both JSON and XML schemas, and it supports event-driven notification. So everything is manipulated by REST. Every object in the APIC can be addressed by a URL, which is a characteristic of a REST-based network. In REST, named resources are a system of comprised resources which are named to a URL. REST can do post, gets, deletes, and updates. You can view this in the HTTPS URL, whether you're using JSON or XML. If you actually take a look at the format here, under API, that will specify the message is directed to the API. The MO class specifies whether the target of the operation is a managed object or an object class. The DN of the targeted management object is the DN, the distinguished name. The class name specifies the name of the targeted class. This name is a concatenation of the package name of the object queried and the name of the class queried and the name of the class queried in the context of the corresponding package, which sounds really weird because it does to me, but hey. For example, the class AAA user results in a class name of AAA user in the URL in JSON or XML. So you can specify whether the encoding format of the command or response for the HTML body is JSON or XML. XML is going to be a little bit easier to actually handle. So you can actually view this right here from a REST XML perspective and JSON. You can actually see the request URL is the same except in XML versus JSON. So you can actually see in XML it's a little bit more straightforward. And you can find more examples of these from github.com Data Center ACI. Deployment options. ACI anywhere, any workload, any location, any cloud. So you can do remote location or remote pod. You can do multi-pod, multi-site, and you can now do hybrid cloud extension. I believe that's going to be in 4.2. So ACI multi-pod is a single APIC cluster that manages multiple pods that are actually connected via dark fiber. So you can see that you have 5 APICs per cluster with a 50 millisecond round trip delay. There's an interpod network between the actual fabrics themselves. So you got pods 1, 2, 3, and 4. So those pods actually connect from the spines out the IPN network, and then they connect to each other. And then the apex can reside in pod 1 or pod 2 or even pod 4. It doesn't really matter. You could have active and standbys as well. So this gives you the option to have a consistent policy for all the pods, centralized management, because remember, you're connecting to a single APIC IP address. So, and of course, if you're on APIC 3, and APIC 3 controls the infrastructure topology, and it has the highest shard, it'll update the database amongst all the other shards for all the other APICs in that physical cluster itself. So you can have a fault isolation by pod, and you can scale with simplicity in this configuration. Now, multi-site is a little bit different. Multi-site automates connectivity through a single management plane that allows you to deploy applications across multiple data centers through common policy. So the difference between multi-pod and multi-site, though, is you have individual APIC clusters at each site. The multi-site orchestrator, or MSO, actually handles all of the policy control between sites A, B, C, and D. So through this greatly simplifies ways to both handle disaster recovery or scale out an application without expanding its fault domain. So customers no longer have to depend on traditional data center interconnect constructs such as OTV to interconnect their data centers. This actually uses Golf. And it also automates the connectivity across sites, and you can scale all the way up to 128 sites. And also has a single policy namespace. So you can allow you to spread applications across sites, move them around as needed, and simplify management workloads. APIC installation. So the APIC hardware ports, there's a console port for direct connection to a console. That's in green. The Cisco Integrated Management Controller port, that is dedicated to a console 1 gig Ethernet connection in blue. Then you have the out-of-band management ports. So they can also be used as SIMC ports. They're dual-homed, and they're configured active-passive. So they will actually go into your out-of-band management switch. Then you have the virtual interface card VIC. So those are the 10 gig VIC cards, and they will connect to Leaf 1 or Leaf 2, what have you. There's 2 fiber optic or 10 gig base T ports for connections to a downlink port on 1 or 2 top-of-rack switches. The APIC, the fabric interfaces, are configured as Linux bond interfaces with active standby failover. And the initial APIC config is via UCS console access. So you can do it console from the back plane, or you can do it from the actual breakout cables on the front plane of the server itself. Initially, when you first get it, though, you need to hit F2 setup, and in the setup utility, choose the security tab and change the admin password. Do not do what a lot of customers do, and they leave it blank. And also don't do what a lot of customers do as well. Walk off and leave it, and nobody really remembers what the admin password is, and no one will ever really figure it out, and then we gotta reset it. The fabric initialization process, the APIC cluster. So that's performed via appliance vector. Okay, so we connect APIC 1 to console and OOB management. We configure the SIMC and initial setup. With APIC 1, we cable to Leaf 1, and then we register Leaf 1 to the fabric. Then we connect all Leaf and Spine nodes, and it should complete fabric discovery. Then we connect APIC 2. So we wait 10 minutes. I always do anyway. Wait 10 minutes after APIC 1, connect APIC 2, make sure APIC 2 is discovered and sees the fabric, and then I wait 10 more minutes, and then I wait for APIC 3. Because what actually is happening is the database itself is starting to build, it's starting to distribute the shards amongst all the APICs, and that's actually the slowest part, but it's the part that we do need to actually pay attention and take our time with. We can also KVM to the APIC console and do that from the SIMC KVM. I will say, as well, as part of firmware, you do need to make sure that that your firmware revision is at the highest level possible. It's not something that's included in all the APIC firmware, but you do have to do the host update utility for the Cisco UCS standalone servers. So this is the initial first configuration screen you will see from the APIC itself in ACI. It's a very simple, very straightforward configuration. Fabric name, cluster configuration, number of APICs, unique ID per, it'll generate a unique ID per APIC device. So what you want to do is you want that to match the number of APICs that you're installing. So it should be 3. You can always add more APICs later. You can increase the cluster, but I don't recommend having an APIC cluster of 11 and then deciding, well, I'm going to be 3. I want to shrink the cluster. You don't want to do that. You want to start at the exact number you're going to need. So what you'll also need is IP address pools for the fabric, the infra VR tunnel endpoints. Make sure that does not overlap with any subnet you expect to reach via the APIC OOB. So that's the out-of-band management network. So really your out-of-band management switch should not be trunking, in this case, VLAN 3967. Then you'll configure your out-of-band management configuration, your admin user configuration, fabric node membership. You'll usually, the group IP outside, you will leave that at 225.0 since that's internal multicast anyway. You'll configure your OOB configurations. Later on in the class, you will actually hear about the things that will require you to rebuild the entire fabric. Fabric name, TEP pool, infrastructure VLAN. You want to change any of those, you have to erase the fabric. You don't want to do that. You want to get that right the first time. So here's how you can manually register. You can assign the ID named switch based on serial number, and that controls which switches can join the fabric and allows zero-touch provisioning of switches. So just because you've discovered a switch doesn't mean it's actually registered to the fabric itself. Or if you have a lot of switches, it's very easy to actually use Postman. And here's the actual code right here. So there's your URL, and there's the payload in XML, and that's all you really need to do: serial number, name, node ID. And you can go ahead and run that against APIC 1 before you've even connected any leaf switches. So you can actually see this. You can do this in Postman runner script as well. So there's the post URL, and then under the body, there's the actual payload to actually set those number of nodes, and then you can have a CSV file, have that point to the CSV file for the leaf, and then the node ID, and then the serial number. APIC GUI features, we'll talk about those real quick. Login settings, remembering where you are in the tree divider, partition, typical stuff. Set the default size for tables, display all hidden UIs and configuration options. Search features are also very handy as well. I need to use them as well because for some reason I cannot, even though I know where it is, I cannot find the attachable entity profile. It's just how it goes, how my brain works. You can search for specific items, or you can type in and it will actually search the fabric itself. So here you can do you can do this in the lab. You can do the APIC login, and then you could actually search for attachable entity profiles, and you can view those there, which really they're under Fabric and Global, but hey. And then you can also do search results. You can search direct context to a management object. The summary view is actually very good. It gives you a top-line look at your topology and pod, as well as your tenants and your application profiles, and then you can dig down to those individual components. You can also view topology by zone. So you can click on Fabric and Inventory and Topology, and you can view all your leaves and spines and apex. And it clearly displays zones for better network management. Now, what zones are groups of switches that are not part of the policy resolution until we actually specify that they're part of the policy resolution universe.